in a mixed reality project room. And Derek Reilly will present this paper, and the co-authors are Andy Echenique, Andy Wu, Anthony Tang, and Keith Edwards. Good luck.
Thanks a lot. Hi everyone, thanks for sticking around to the very end of the day. I guess we have a reception afterwards, so that's incentive as well. But it's good to see you all here. Yeah, so this work was done at Georgia Tech. A lot of us, most of us, are elsewhere now, except for Keith. Keith is still holding down the fort at Georgia Tech, and that's a good thing. All right, so my talk is about mixed reality project rooms. So I'm going to motivate the concept first. Then I'm going to talk a little bit about some related work and present a study that we did where we looked at the impact of the physical layout of a project room and the activity conducted in the project room on how people form a cognitive map of the connected virtual world in the mixed reality project room. We'll look at a layout by activity interaction effect and look at the impact of other factors that influenced how people formed cognitive maps. In the discussion, I'm going to talk a little bit about conflicting versus complementary cues and the impact of cognitive maps on collaboration. In conclusion, talk a little bit about whether we actually need accurate cognitive maps of the connected virtual world to collaborate effectively in a mixed reality project room. Okay, so a mixed reality project room. What is a project room? A project room is a room that is dedicated to a project over its lifetime. They tend to promote team cohesion. They're used for a variety of different activities through the course of the project. And because the space is owned by the project, the space comes to take on meaning. There's visibility of shared status. There are designated zones for different kinds of activities. And there are sort of common rituals that are spatially located, like the location of a daily stand-up meeting, things like that. What you're looking at here is a dark virtual model of the InSpace Lab, which is a project room that was co-designed at Georgia Tech with collaborators from Steelcase Workspace Futures. And I'll give you a brief tour. There are three main work areas. There is a typical conference table for meetings. There's a brainstorming area with high cocktail seating. And there's a high seating table for active table work, collaborative table work. So the problem with these project rooms is that not everybody is at the same space. Not everybody goes to work at the office, right? So there's telework. People are working from distance. People are telecommuting all the time. So we want some way to allow these remote collaborators to connect with the project room in a way that doesn't break the affordances, the nice aspects of having a space that's dedicated to project work. So we looked at mixed reality as an option for doing this. So essentially, we have linked points of collaboration, like this whiteboard. Audio communication is spatialized so that remote collaborators are heard at the physical whiteboard and vice versa. We looked at a couple of different models of the project room to map and to create a virtual model of. We tried a strict what you see is what I see approach. First, during demos, this was compelling for visitors, but almost impossible to use because as an avatar, you're constantly bumping into chairs, documents are really small, it just wasn't feasible. So we then tried a relaxed WYSIWIS approach. The documents are more pronounced, the scale had changed, the furniture was completely skeuomorphic. There was an emphasis on visibility and navigability of the virtual space. During demos, however, we found that people had a hard time kind of comprehending that there was any kind of spatial correspondence between these two spaces and seeing sort of which areas map to which in the physical and virtual. So with our collaborators at Steelcase, we built on the idea that the physical space itself should influence the perception of the connected virtual world and that we can design around that. Because a virtual world that's laid out as we expect it to be will be easier to comprehend and to consider as part of the collaborative environment by those in the physical room. So the purpose of the study that I'm going to present today was to explore this idea, to begin to understand how the physical environment influences our perception of a connected virtual space. But first, a little bit of background. So I'm just going to briefly highlight some key work that was very influential in our thinking. Of course, the media space work, they were interested in the perception of fused spaces, how we can link spaces semantically using the locations of cameras that take advantage of the layout and meaning of different spaces. The cooperative buildings research, you can see some of the same references as some of the previous work presented in this session, looking at the architecture of spaces, furniture, and technology, fusing them, doing that together to support collaborative work. This work discusses but doesn't implement or study remote connectivity with such spaces. Of course, mixed reality in general, and here's one example, Uncle Roy all around you. This example, players in the virtual world move about a virtual city, and they can interact with players at the same time in the same locations in the actual city. Mixed presence groupware, so this is the idea where you might have heterogeneous interfaces that converge to create a common model for shared work. The emphasis here is on visibility, awareness of action and intent, supporting natural gestures. So now our study. For our study, we brought in 12 groups of 3 participants. We had 2 co-located in the project room and 1 connected remotely via virtual world. They were recruited across the Georgia Tech and Emory campuses, and they had a variety of exposure to games and technology. We had 2 different layouts in our study. The idea here was that a change in the layout of the furniture only in the project room would influence how the virtual world was perceived. So the display positions didn't change. Because we believed also that activity would have an impact on this perception, we designed 2 different activities. So we designed an itinerary planning activity that used display D up at the top for a separate subtask, reinforcing the separation of 2 zones, and an image search task that used display D in the same way as the other displays, working against this separation. We employed then a 2x2 counterbalanced within groups design with the factors of layout and activity. So briefly talking a little about the 2 tasks. The itinerary activity involved planning a 3-day group holiday. There were 2 subtasks, as I mentioned. The first was selecting items which occurred on the bottom 3 displays in this sort of cove region, displays A through C, containing image, text, and map content, respectively. And then scheduling happened in display D. We mapped the virtual world in the physical room. The physical room's on the left, the virtual world's on the right. We had a dial in the cove area that would switch the content category. So we turned the dial and we would move to a different category. All 3 categories were represented at the same time in the virtual world, and what rotating the dial would do was to change the position of our avatar in the virtual world. And what this meant was the remote collaborator needed to pay attention to where our sort of camera avatar was, because that's how he knew where we were, and in order to hear and be heard, he had to be close to us. Okay. The image search activity involved finding an image from among 200 color-matched images, divided into 4 image grids, 1 on each display. This is a very singular task. We did 10 rounds per condition, similar content across all displays. Again, the idea here was to work against a division based on layout. We mapped the real and virtual in a sort of more straightforward way. There's a simple left to right correspondence, image sets to displays. However, we introduced audio holes such that image sets 1 and 3 had audio connectivity, while image sets 2 and 4 did not, introducing some challenge in coordination. Okay, so the measures, we had video we captured in room and remotely. Individuals in the project room sketched their perception of the connected virtual world after every condition, and then the 2 individuals who were working in the project room came together to do a placement activity where they placed physical versions of the content on a 2D top-down view of the virtual environment. And we had a post-session interview where we brought the remote collaborator in. They had a discussion as a group. So the results. First, we looked at sketch similarity. So are collaborators' sketches similar, more similar than, say, some random other person in another group? We found that there was no difference in sketch similarity for the itinerary task, but more similarity within groups for the image search task. And we take away from this the idea that mental models converged if they were needed for collaboration, because as you'll see in a minute, they were less necessary in the itinerary task. A second result, we asked the question, if is the display D actually separated in the sketches? We found a main effective task, so as we expected, the itinerary task reinforced this idea of two different regions, and there was more separation than in the image search task. We found no main effective layout by itself, but there was an interaction effect of task and layout for itinerary. So in the itinerary task, when there were two tables, there was more of a distinction between display D and the rest of the content than when there was one table. There were related results also in the paper for similar phenomena. And this just shows you some of the sketches that were done for the two table layout condition versus the one table layout condition. The one table layout condition, the display D is sort of grouped with the other displays. Okay, so look at the impact of some other factors. There were semantic associations of the task content, and that impacted cognitive map formation, in particular for the itinerary task. Transitions between the different content categories was mostly done by category name, not by left, right, first, second. Within a category, it was easy to distinguish between map, text, and image documents by type. You know, look at the map, look at the images. When it was time to build a schedule, let's just go to the schedule, let's go over there. As a result, we had a number of sketches that grouped the documents in a grid, sort of by category and then by type. Some participants mentioned it wasn't necessary at all in this task to understand the layout of the virtual world. This wasn't the case in image search, where there were no semantic anchors whatsoever. All the documents were the same, so most groups used a left to right ordering scheme in that case. The virtual environment also had an impact. This is an area that needs a lot more exploration. We changed our virtual world backgrounds to nondescript ones after using office themes in our pilots, because pilot participants were making inferences based on office objects visible in the virtual world. So during the study, however, some participants were still sort of trying to see correspondence, visual cues in the virtual world, and using that to form their mental model. In the bottom right here, you see the sketch done by one such individual. Others, however, didn't really pay attention to the virtual world at all. And we'll look at that in just a sec. The third factor that influenced mental model formation was the interface itself. So the dial and the audio holes in image search. So we'll look at the audio holes first as an example of a conflicting cue, something that conflicted with the layout of the displays, left to right correspondence of displays and image content, but there were audio holes for image set 2 and image set 4. Some thought that because there was no audio for image set 2 and image set 4, this meant that these were further away in the virtual world. Others, as you can see here, simply thought there was some kind of unknowable separation between these two groups. And conflicting cues like this can hurt collaboration. In this case, it made it more difficult to establish a common scheme for identifying the image sets and for coordinating movement between these image sets. So we have got another example here of cues sort of reinforcing each other. And I'll just read the quote first. So when we rotated the dial, I assumed we were just rotating around. The remote participant told us they were all in a line, that is, the content was all in a line, but that didn't seem intuitive to me, so I thought he was wrong. So this is a strong influence. The reinforcement is between the dial and the cove-like representation of the content, the way the displays were represented in that region. If the virtual world were to have complied with that expected model, that might have been a good thing. In fact, it didn't actually make much of a difference in collaboration in our particular case. It's also worth noting that not everybody picked up on this reinforced cue, perhaps because there were always quite a variety of cues to consider, which is important to consider in design. We've got a lot of competing cues, and people are picking up on different ones to try to understand the virtual environment. Okay, so the last thing that I want to look at here, if we can, that's really going to be really difficult, but we can listen and pick it up, is the idea of virtual world blindness. Here's this is project room blindness here. The first thing I want to point out, I'm going to show a video clip, is that similar to other GROUPWARE, different interfaces between remote and co-located collaborators can be an issue when coordinating work. And then talk about how that correlates to cognitive maps. Okay. Oh, no. 1 second. Where is that? Okay. Okay, so in this clip, two things are happening. The first is that the remote collaborator thinks that number 3 is meaningful to the in-room collaborators. He could press 3 hotkey on his keyboard, and it would move him to section map to the number. They had no such correlation. They just had the dial. They luckily went to the same location when they turned the dial. It was pure luck. So they maintained audio connectivity, and then they figured out there was a difference. Secondly, even though they could hear the remote collaborator, they didn't associate that with the fact that the remote collaborator could see what they see. So they didn't have this model that audio connectivity meant they were in sync and they could look at they were looking at the same content. This belies the underlying problem here, where the in-room collaborators really didn't have a sense that there was a virtual world at all. So, in fact, the one who had the dial says that when I was turning the dial, I didn't notice that the background was changing at all. And here's our sketch, which sort of is a 2D sketch. There's no virtual environment. Despite this, though, the group worked quite effectively together. They relied on content attributes, and each side kind of managed their own transitions without needing to know how it was done necessarily. What was crucial was the visibility of the location of the in-room participants in the virtual world. That was used by the remote collaborator, and not a shared model of the virtual world. Okay, so to conclude, cognitive maps converged when they were used in collaboration. The physical room layout interacted with activity to influence the formation of cognitive maps. Cognitive maps were influenced by other cues, so content attributes, interface, and the virtual world. And these cues can either conflict or complement each other. And finally, like other collaborative technology, what is most necessary are anchors for coordination, for communication, awareness of action, and intent. A shared cognitive map can help, but it's not sufficient or even necessary for effective collaboration. And with that, I'll say thank you very much and take questions.
Derek, thanks for your nice presentation, and we are a little bit over time, but maybe 1 or 2 questions. Okay, no questions anymore. We are too much over time, so thanks again for your nice presentation.
Yeah.
Derek.